Hello everyone, my name is Suryavanshi Balkrishna Shivaji. I am a student of the BSc Honours in Data Science in AI online degree program at IIT Guwahati. Student ID is 230350102250 and the course code is DA377 and term project 1 trimester 7. Uh, in this video, I am presenting my term project on the comprehensive risk modeling, specifically value at risk, expected shortfall, and the WARE model backtesting. The project covered the three areas: portfolio construction using the MO and the three different WARE calculation method and the two regressive backtesting approach will all wrap up in an interactive sim web application. In the financial market, bank and the portfolio manager face a fundamental question every single day. How much money could I lose tomorrow? And the more importantly, what is the worst case loss I should prepare for? This is exactly what the value at risk answers. Value at risk is a statistical measure that tells you the maximum expected loss over the specific time period at the given confidence interval. For the example, if I tell you that a one day where at a 90% confidence is rupees 32,000, that means there is a 99% chance that tomorrow's loss will not exceed 32,000 rupees. But there is a 1% chance that could lose with a worse. Where is a industry standard? It required by the Basel 3 banking regulation used by the central bank, investment bank, and every major financial institution globally. Now the where alone has one limitation. It does not tell you how bad the loss could be if the thing go beyond the threshold. That's where the expected shortfall comes, also called the conditional where comes in. And the third key component is the back testing. When you build a war model, you have to test. And was it accurate? Did the actual loss in the past match what the model predict? That is what the back testing does. The tools and technology used for this project are the Y-Finance to download the market data, NumPy and the Pandas for the numerical computation and the data manipulation, SkyPy for the optimization solver, and the statistic stats like a cubic stat and the polity for the interactive data chart. For the web application, I use TeamLead, which let you build the interactive data app entirely in the Python without needing any front-end web development. The project is organized into the four folders: portfolio construction, where calculation, where backtesting, and the Streamlit app, making each component modular and the independently testable. Now let me show you the data I work with. The data set consists of the daily stock price for the three major US financial stocks: JP Morgan case, JP Morgan case, Morgan Stanley, and the Bank of America, covering the 1566 trading day from the January 2019 to December 2024. The data is structured as a CSV file with the data index and the one price column per stock. For this, I compute the simple daily return using the formula. The return on the day T equals to day and today's price divided by the yesterday price minus Y. Now let's walk through the code. Let me start with the portfolio consolidation model. The goal is here to the optimal allocation across the JP Morgan, Morgan Stanley, and a Bank of America that maximize the Sharpe ratio, which measure the return per unit of a risk. I am using the Morgue mean variance framework. The key function here is the negative Sharpe, which calculate the negative Sharpe ratio because the Sharpe minimizer minimize, so we negate the objective to the effective Sharpe maximization Sharpe. The construction are the weight must be sum equal to 1, full investment, and the each weight must be 0 to 1, no sorting. I am using solver sequential least square programming which handle this constraint effectively. Done. Now the where calculation model. This is the heart of the project. I have implement three methods. The method one, historical simulation. This is a non-parametric. It makes no assumption about the shape of the return distribution. I take actual historical portfolio return, sort them from the worst to best, and find the rank at the 1% rank. With the 1565 observation, the 1% rank correspond to position 6, and that the 6 daily return is my Y return. The method two, the covariance method, also called the parametric method. This assumes that the return are normally distributed and the key formula is where equal to the mean portfolio return plus the Z score times the portfolio standard deviation. At the 99% confidence, the Z score is a negative 2.33. The portfolio standard deviation is computed from the covariance matrix as the square root of the W transfers times sigma times W, where the W is a weight matrix and the sigma is the covariance matrix. The method three, the Monte Carlo simulation. This is a most sophisticated approach. I model each stock future price using the GBM, the standard stochastic model for the stock price in the quantitative finance. The key challenge is that the three stocks are correlated, so that I cannot just generate an independent random stock. I use Cholesky decomposition of the covariance matrix to generate a correlate random variable. Then I stimulate 10,000 one-day return scenario exact where from the first percentile of the simulation. Now I will go to the backtesting model where text my where model is accurate or not. For this, I use method one, which is traffic light approach, which is the base three standard for the bank. I look at the last 250 trading days, approximately 1 year, and the count how many times the actual portfolio loss exceeds the where estimate. This is called the breach or the violation. The, the base framework classify the model into three zones. Green if the 0 to 4 piece, yellow for the 5 to 9, red for the 10 or more. Green means the model is working well. Red means it is need to recalibrate immediately. The model 2, method 2, the cubic proportion or the of the failure test. This is a proper statistical hypothesis test. The null hypothesis is that the observed base rate equal to the theoretical 1%. I compute a likelihood ratio statistic comparing the likelihood under the null versus the observed data. The statistics follow a chi-square distribution with a 1 degree of freedom. So I compare it to the critical value of 3.84 at the 5% significance. Start. Now let me walk through the actual output. For this, I will run the command on the streamlit. Now I will run the command. Starting with the portfolio optimization result, and the efficient fund trail chart showed up 5,000 random generated portfolio. Each point represent a different weight combination. The yellow star marks the max sharp optimal portfolio. The green diamond mark the minimum variance portfolio. The market optimization allowed 100% of the portfolio to the Bank of America. This is a corner solution which happen in the small universe when one asset dominates on the risk asset return over the estimation period. Now the where result. All three methods are remarkably consistent, which is actually a good sign. Historical simulation gives the 3205 dollars. Variance covariance give 3 to 1 for $1. And the Monte Carlo simulation gives 31676. The spare is less than the 500 across the three completely different methodology. This converse tells us the return distribution is exponentially normal and in making all the three approach value. The expected shortfall result are slightly higher, averaging around the 36000, which tell us on the day when the loss exceeds the world west threshold, the average loss is about the $30,000 rather than stopping exactly at the $32,000. Now the backtesting result. Let me show your which timeline is red cross marked a day when the actual portfolio loss exit the war estimate. In the last 250 trading day, there was a 4 rupees. This fall in the green zone 0 to 5, 0 to 4, meaning the model is performing within the acceptable limit as per the base 3 standard. So let me summarize what is project achieved. I built a complete end-to-end risk modeling pipeline, starting from the raw market data, the Markov optimizer, and the found the maximum Sharpe ratio portfolio. The three independent WAR calculation method, historical simulation, where covariance, variance covariance on the Monte Carlo simulation, or converse to the one day 99% aware of the exploratory $32,000 on the 1 million portfolio. The backtesting confirmed the model works and the traffic light approach placed the model firmly in the green zone with just freezing in the 3 days. The cubic P of the cubic P of F test return a p value of 0.87, strong statistical evidence that the model is correctly calibrated. One thing I learned from this project is that the WARE methodology is not just about the calculating the number. It about understanding the assumption behind the each method and the knowing when they break down. The historical simulation is assumption free, but the backward looking. Variance and covariance is a fast, but the assume normally which may not hold during the market crisis. And the Monte Carlo is the most flexible, but the computationally expensive. Thank you. This was my project.